In this video, we're going to go over the notes for the function rule. So our first part is the function rule of a sequence can be written as A sub n equals D times n plus B. So for these next four lines, we're just going to define what each part of the sequence means. So we have A sub n, which is the value of the term n. Okay, and the next one, D, is going to be our common difference. So this is going to be what we're adding each time or subtracting each time from the sequence. Then we have n, which is going to be the number of the term. So first term, second term, third term. And then we have B, which is a new one. That's going to be our y-intercept if we graph it. Or our A sub 0. And A sub 0 is just going to be the number that we would get if we used the difference to find the number before the first term. So now we have our first example. When we're given a value for D and A sub 1, we can use the explicit rule to find the function rule. So our explicit rule, if you remember, is A sub n equals A sub 1 plus D times n minus 1. Okay, and we're going to use that to find the function rule. So for our first example, we have D equals 2 and A sub 1 equals 1. So we're just going to plug those in to the explicit formula. So we have our A sub n equals, our A sub 1 is this 1. Then we're going to add D, which is 2, and the rest of the formula, n minus 1. Then, in order to change it to our function rule, we have to distribute this 2. So what we're doing is multiplying 2 times n, and then multiplying 2 times negative 1. So we have 1 plus 2 times n is 2n. Then 2 times negative 1 is negative 2. Okay? Then we combine like terms, which is this 1 and this negative 2. And we get negative 1. So we haven't done anything with this 2n. So we're going to bring down the 2n. And then negative 1. So our function rule is going to look like that. A sub n equals 2n minus 1. So if we move to our next example, example number 2, we're going to use the following sequence and the function rule to create a general equation for the sequence. 9, 7, 5, 3, and so on. So for this, we first need to find our A sub 1, which is always going to be our first term in the sequence. So in this case, it's 9. So A sub 1 equals 9. Okay? And then we have to determine what our difference is. So how we get from 9 to 7 to 5 to 3. So from 9 to 7, we're going down by 2. And then from 7 to 5, we're going down by 2. And from 5 to 3, we're also going down by 2. So our common difference is going to be negative 2. Okay? And then we plug that into our explicit formula. So we have A sub n equals A sub 1 plus D times n minus 1. Okay, so we're going to plug in our numbers again. We have our A1, which goes here, and our D, which goes here. So we have A sub n equals our A1, which is 9, okay, plus D, which is negative 2. So we're going to put minus 2, because plus negative 2 is the same as minus 2, okay, times n minus 1. So that's our explicit formula. And then we distribute, so that's the next step, this negative 2. Don't forget to bring that negative. Okay, so now we have 9, because we haven't done anything with the 9 yet, minus 2 times n. Well, negative 2 times n is negative 2n, so minus 2n. And then negative 2 times negative 1 is positive 2, so plus 2. And then we combine like terms, 9 and 2. 9 plus 2 is 11. So then we have A sub n equals negative 2n plus 11. And that is our answer for example 2. So we're on to example 3, which says create an equation for the sequence using the function rule and the information given, then find the 15th term. So here's our information for that question. So we're going to just use this to find the function rule. So we have our explicit rule, which is A sub n equals A sub 1 plus D times n minus 1. Alright, so now we're going to plug in our A sub 1 and D. So we have A sub n equals A sub 1 is 9. So that goes there. Plus D is negative 3. So we're going to put a minus 3. Okay, times n minus 1. And then the next step is to distribute this negative 3. Do not forget to distribute the negative also. So we have 9. And negative 3 times n is negative 3n. And negative 3 times negative 1 is positive 3. So we have a plus 3 there. Then we're going to combine like terms. So our like terms here are 9 and positive 3, or this plus 3. And then combining those, 9 plus 3 is 12. So we have A sub n equals negative 3 n plus 12. Okay? But this question also said find the 15th term. So we're looking for the 15th term. The number of the term is n. So for the 15th term, we're going to go to A sub 15 equals negative 3. We're replacing that n with 15. Okay? Because it's the 15th term. Plus 12. Okay? So then we are going to multiply negative 3 times 15. We get negative 45 plus 12. Okay? And then negative 45 plus 12 is negative 33. So our answer is A sub 15 equals negative 33. Now we're on to our last question. Our example 4 says a new candy store has opened on Fiction Street. To promote the grand opening, the store has given away chocolate truffles. 10 free truffles will be given to the first customer, and each customer after that will receive 3 truffles. So here we have 10 are given to the first customer. So this 10 is going to be A sub 1. And then every customer after that receives 3. So 3 is going to be D. Okay, so list the first 5 terms of the sequence representing truffles given away. So if our first term is a sub 1, that's 10. And then we're adding 3 each time, because that's what that D says. We're adding 3 each time. So the next term would be 13. And then plus 3 is 16. Plus 3 is 19. Plus 3 is 22. And then we have all 5 terms. Okay, so part B. If the store only gives truffles to the first 100 customers, how many truffles will need to be made for the promotion? So we're going to use our formula for this part. So the formula is only giving free truffles to the first 100 customers. Then 100 is going to be our N. Okay, but first we need to find our formula. So we're going to start with the explicit formula. An equals a sub 1 plus D times n minus 1. And then we're going to plug in our numbers. We said that a sub 1 is 10 and D is 3. So those are the numbers we're going to use. So we have a sub n equals 10 plus 3 times n minus 1. Okay, and then we distribute the 3 to the n and the negative 1. And we get a sub n equals 10 plus 3 times n is 3n. And 3 times negative 1 is negative 3. And then we combine our like terms, 10 and negative 3. So 10 minus 3 is 7. Our answer is a sub n equals 3n plus 7, because 10 minus 3 is 7. So that's where we got that 7 from. Okay, so now we need our 100th term. So we're going to plug that in to our function right here. So we have a 100 equals 3 times 100 plus 7. Okay, so 3, it's a positive 3, it looks like a negative 3. 3 times 100 plus 7 is 307. Okay, and that is our answer. So they only give truffles to the first 100 customers. They will have to make 307 truffles for the promotion. So this last example, what formula would model the number of truffles being given away at the grand opening? You can use the example from above, but if you want to do it just one more time, we have a sub n equals a sub 1 plus D times n minus 1, which is our explicit formula. And then we're going to put in A1 and D. We're going to substitute those in. So we have A1 was 10, and then D is 3, because the first person gets 10, and everybody after that gets 3, times n minus 1, because that's the rest of the formula. And then we're going to distribute again. 3 times n is 3n. 3 times negative 1 is negative 3. So we get 10 plus 3n minus 3. And then combining like terms, 10 and negative 3, we get 7. So we have 3n plus 7. Okay, and we're done. That is the formula that will model the number of truffles being given away at the grand opening.